Alex Kennis again, and time for part 4 of the RAMPS series. Now, this part of the series I've been putting off and dragging my feet for a while because it's so boring. But it's important and it has to be said, so let's just get it over with. This video is about these guys, which are the infamous RAMPS polyfuses. Now, a little bit of background on the design of the board. The RAMPS was originally designed by a guy named Johnny Russell, and I think he did a pretty solid job, but the industry has sort of grown apart from the intents of these original designs, so they've been iterated through from, RAMPS to RAMPS 1.1, 1.2, 1.3, 1.4, and that's all just kind of an attempt to grow along with the community. At the time, just before the RAMPS board came around, the riprap world were literally etching their own boards or building 3D printers out of these proto board sticks and just putting the drivers and a bunch of jumpers on there. And the problem is that wasn't very easy and it wasn't very accessible, so it was nicer to have basically just an Arduino shield that plugged into a Mega, and the Mega itself is basically just a fancy breakout board for the processor. So the point was leverage existing technology, i.e. the Mega breakout board, so that all of that work, all of that layout, and all the production was already taken care of, and then stick a shield on top with a few passive components and a few active components and some sockets. Now, the shield needs to be powered because we are going to be running high-powered steppers off of these, which require a couple amps of current apiece at a higher voltage than the Arduino runs. Now, anytime you're talking about a decent amount of amperage in a circuit and experimental wiring, experimental steppers and user error and all that stuff, you need safety precautions. But when it came to the RAMPS board, it had to be A, really small, and B, really cheap, and C, easy to manufacture. So the thought was use resettable fuses. They're a lot cheaper than a blade fuse in a socket, and if you have a catastrophic problem, they'll trip, you power it off, wait for them to cool down, bring it back up again, and you're good to go. But the problem lies in the fact that people were doing higher powered boards, like the original PCB heater board that Joseph Prusa gave to the community so many moons ago. Now there were companies that were manufacturing these, and they didn't necessarily have to stay in tolerance. So in a system where everything's kind of running on borderline anyway, you're bound to get some manufacturers that make some boards with a little bit low impedance, or they do it on purpose. They could say, I want this to be a higher wattage board, so let's drop the resistance down so it'll pump more heat out. Well, polyfuses, as opposed to regular fuses, have particular operating conditions that they're supposed to be under. Now, what these are, at their core, are just carbon particles suspended in a polymer matrix of some kind and dipped in epoxy. It's broken out on 2 leads, and they have 2 states, a high state and a low state, in terms of high resistance and low resistance. When too much current is sucked through these, the heat generated causes the state of the carbon particles to change the conduction of the device, and then it changes states. And the point of that is that as it raises the resistance, it drops the current coming out of it to a trickle, and it saves whatever you have plugged into it from impending doom of whatever you've done. Now, polyfuses have 2 ratings that you have to be aware of. One is the holding current, and the other is the trip current. The holding current is usually specified on the polyfuse itself as part of the part number. So this one happens to be one of the bed polyfuses that I pulled off of one of my RAMPS boards, and it's rated at 11 amps at 16 volts. Now, the reason I pulled it off is because I wanted to go to 24 volts. Obviously, this is not going to meet that rating, so it had to go. Now, since you can get more power at less current out of higher voltage, i.e. you can get a hotter bed out of less current at 24 volts than you can at 12 volts, these are also essentially useless at 24 volts when they're rated for 12 volts, because you're not going to get anywhere near 11 amps on a 24 volt bed. Well, if you're a crazy person, you might. I mean, that would be like 220 watt bed, or no, more than that, almost 300 watt bed. But regardless, these are meant to be run at the holding current. And then there's a little bit of a range, and then there's a trip current. So for our 5 amp polyfuse that protects all the 5 amp circuits, that trip current is usually 10 or 11 amps. And then for this 11 amp polyfuse, it's usually like 17, 18, 19 amps or something like that. Now you might think, well, if 11 amps is too much, then why is the trip current so much higher? By the time we reach 18 amps, we're already on the bleeding edge there. Who knows, our gizmo could have melted down by then. Well, that's where some of the benefits of polyfuses come from and some of the confusion. So you can go a little bit over with these and they'll probably be alright if you do it for a short period and then they cool back down, because they have a variable time to trip depending on how much they're being beat up. But the bad part is their holding current rating drops depending on the ambient temperature. So again, this comes back to whether or not you have a board cooling fan, whether or not you have your control board inside a heated enclosure, which is not the best idea. But they're meant to hold at 25 degrees Celsius. And if you open up one of the data sheets and look at the derating curve, you'll see that if you up that to 50, you're going to drop 10% of your value. And then it just gets worse from there. If you up that to 75, you're losing 30% of your value. And then if you go up to like 100 degrees Celsius, you lose up to 70% of your value or more depending on the device. And it'll end up practically tripping if you just look at it funny. Now what you're supposed to do when it trips is remove power and let it reset. This is where another one of the problems comes in with polyfuses with respect to the RAMPS board, because they don't have an indicator. Now, you could arrange an indicator with an LED and a resistor just in parallel with the polyfuse, but that's just not something they did for some reason. And then at least you would know, hey, I should turn my printer off and wait a couple of minutes for this to cool down. But instead, what'll happen is, let's say you're running a bed and you've exceeded this, not necessarily 11 amps, but you exceeded the holding current. Let's say you're running it a little bit hot and your bed is pulling like 8 or 9 amps or something like that, which happens to be too much. So it starts to heat up and raise its resistance, and then it might cool down and start going back to the low state again, heat up, go to the hot state, cool down to the low state. And people have these weird problems with their printers where they're having this bizarre erratic behavior that it's hard to diagnose because there's no indication that this is actually tripped or not. Now some of these are nifty and they change color when they're tripped, not the ones we use on the RAMPS board though. Second part of that reset issue is it's going to reset mostly in the first minute or two, but that cooling curve drops like a stone out to about like 5 or 10 minutes, and then it's real gradual reset over the course of like days and weeks. And it may never get back to its initial value. So every time you trip it, you might be derating the device more and more, and eventually you just get a printer with a hot bed that's wacky. So does that mean that they're automatically bad? No, it just means that they're being used wrong, and that there's no way you can tell if it tripped. Again, the price of these is, you know, pennies or dozens of pennies, whereas the price of an automotive fuse is $1 or a couple dollars, and plus you have the holder, more board real estate, and every time you blow one out because you did something dumb with your heat bed, you have to plug another one in. But the benefit of fuses is that when they're gone, you're gone, you know it. And if you change your hotbed or change your power supply or whatever it is you change, you could just yank that fuse out and then plug another fuse in there that's the appropriate rating. You also don't have to worry as much about the voltage rating, because typically like automotive blade fuses are rated up to 32 or 36, 32 volts, I think, typically. So they're fine with our 12, 24, whatever power supplies. Whereas polyfuses, they have the current and the voltage rating. So like I said, I pulled this one off of a board I wanted to use 24 volts because 16 volts just isn't going to cut it. But don't think that that means that these are empirically bad and they're going to burn your house down. Because even these people that are just absolute polyfuse haters, they're going to pull them off and then take a switching power supply and plug that into their board, and your switching power supply is full of polyfuses. They're just used properly. They know what's going to be plugged into it, so they can rate them sufficiently, and they have other controlled circuits to make sure that the cooldown time is right. If you, like I, have ever accidentally shorted out an ATX power supply while you're doing some dastardly experiments, you know all about letting it sit there and reset. And after 5 minutes or so, it powers back up just fine. Now, have I used polyfuses in my personal designs over the years? Not really. They're good for like motor protection, and they're good if you're going to get occasionally like voltage surges or something like that are not catastrophic, but you don't want them to blow out a fuse, and you don't want to have to overrate the fuse so that it doesn't pop. They're also good for if you have to stick it someplace squirrely that you can't get to in a circuit, but you still want some kind of protection. But mostly I'm concerned with safety, and if I were doing something from scratch, I'd probably just use blade fuses. But like I said before, I run a lot of my printer experiments at high voltage anyway because it's better. And so as long as these fall within the right voltage rating, I don't care if they're sitting there because I'm not going to get anywhere near the hold current, but I'll also use an inline fuse just to be safe. But if you have a board where you know your MOSFETs and you know your connectors and you know your power supply are able to and will be pumping out more current than the holding current of your polyfuses at that particular temperature level, you can go ahead and bridge them, i.e. short the legs together, and that'll basically take them out of the circuit. Or you can desolder them from the board and solder a jumper wire in their place. Bridging them is less risky to the board because there's no chance of you peeling the copper traces off and ruining it. But if you do bridge them, that means you have absolutely no safety circuitry except what's in your power supply, which may or may not be anywhere near a low enough trip level for something like a hot end that's going goofy and caught on fire or something like that. So absolutely make sure you have some kind of fuse. I searched high and low for the purposes of this video for an easy fuse socket that plugged into the same footprint that they made on the RAMPS board for these polyfuses, and I just couldn't find one, unfortunately. But you can do like I've done in the past and take spade terminals and solder those to the board if you want an onboard solution, or you could just run wires off the board, like jumper wires, to a mini fuse box that you could 3D print and have your blade fuse sockets or your cylinder fuse sockets in that. Or you can use an inline fuse before it even gets to your connectors. And that might actually be better because if you have some of the crappy green RAMPS connectors that start getting a little corroded and overheating, it might add a little bit of extra protection for it depending on how it fails and if it shorts. But anyway, I won't bore you with polyfuses anymore. That's the video. If you have any other questions about these, I don't know what you could possibly ask, but if you do, just leave the questions in the comments. I check them a couple times a day. If you catch me when I'm not in the middle of something, I'll try to answer them. And if you appreciate these videos and they help you out, I have the support links in the description. And I'm actually really excited to get to the last part of this RAMPS series because I could do kind of like a roundup and like what's going on in the future and that sort of thing. And I'm eager to both record a video about all of that and to start a dialogue with you guys about all of that, because as you know, the post-RAMPS world is kind of a mess right now. So I'll get on writing up my notes for that, and until that video comes out, get out there and make something awesome.